Technology is everywhere, and so should a systematic philosophical reflection on technology. The Working Group on Philosophy of Technology, WGPT, at the University of Leuven in Belgium aims to create a platform to do precisely that. You're listening to WGPTalks, a series where we give the opportunity to our own members to talk about what fascinates them at the crossroads of technology and society. Today we talk with Hannes Van Engeland on Phenomenotechnique. There is a saying by the engineer John Kempert that every rocket firing that is successful is hailed as a scientific achievement. Everyone that isn't is regarded as an engineering failure. When we talk about science, we typically refer to technological engineering achievements. We think about new technologies like your iPhone, we think about rockets to the moon, etc. But we hardly ever think about what specifically is the relation between science and technology. How is science related to technology? Is it the same? Is it different? Is one the product of the other? Today we talk about that topic with Hannes Van Engeland, who is here with us. So let me immediately pose that question to you, Hannes. What are the possible relations between technology and science? How should we understand both in relation to one another?
Well, typically you would say that the relation between science and technology is pretty straightforward. What you just said, the rockets to the moon or your iPhone or other scientific things aren't possible without technology. Technology is the means we have to discover in science. Anything that's not technologically made is just some kind of science fiction, you could say, or some kind of mathematical poetry.
We need technology to make science concrete.
Well, that's one option, yes. But on the other hand, I would say that also that view is maybe a little bit off, because you also have something like mathematical technology, like matrix calculations, or think about wave mechanics. It's something as simple as algebra is actually a mathematical piece of technology that we use. So technology is not just something material to make science, to bring it into the world, so to say, but it's also something in the world of ideas, so to say.
So there are different possible ways to relate science and technology. One is the one I suggested. You have science and then you make it concrete, make it specific in the form of technology. And technology then is some kind of applied science. But you are suggesting different ways to understand that relationship. How would we then conceptualize that relation? Are they the same then? Is technology the important element and science the product of technology?
Another idea is that, well, science uses technology to progress on the one hand. So it's not just to make it more concrete, it's also a tool. If you have a piece of technology that can help you to manifest your theory, that's one thing, but it also can, again, the case of algebra, you can use mathematical tools to construct a theory, which you then are going to test experimentally. But it also can be used to, well, make the science even before it actually happens. So sometimes the technology precedes the science.
And technology is then kind of a means not to get the product, but to even produce science and scientific results. You mentioned the case of algebra as a kind of technology. I think this might surprise many of our listeners, basically. What does that mean to say that algebra is a technology? I think most people relate technology to a very material thing. You seem to have a different view on the matter.
Well, to give an example of mathematical technology, think, for example, about non-Euclidean geometry. If we want to indeed launch the rocket into space, we will also need to understand that the Earth is a globe, and that to land this thing back where we first launched it or where we want to have it land, we will need the geometry to do so. So we shouldn't view Earth as a flat piece of paper, but as a globe, which brings in different kinds of geometry than we are used to after we have done secondary education. Another example is we think about 2D and 3D very easily. But if you add more pieces of mathematical technology, you end up with 4 or 5D spaces and many more dimensions, which can lead to new things in, for example, string theory. So these are mathematical technologies, I would say, that can help to construct science rather than just materialize it.
And they are technology because there are some kind of tools that instead of extending the reach of the hand, they extend to the reach of the mind. Okay, that's fascinating. I don't think it's an accident that you use the example of mathematics as a tool, because it's central also to the author that we are going to discuss and his concept, namely Gaston Bachelard and Phenomenotechnique, which is his way to understand this relation between science and technology. But perhaps first, let us ask, who was Gaston Bachelard?
Indeed, sadly, he's not very well known, well, outside of France, that is. He was a French philosopher of science. He was born by the end of the 19th century, got into philosophy later in his life after he already was a chemist. He worked at a post office as a postal officer, and after teaching in high school for a couple of years. So only after this basically half-life, he then turned to philosophy. So he was a chemist, become philosopher, and he turned to philosophy of science. And in the philosophy of science, he became one of the biggest names in France at that time, comparable to, let's say, Reichenbach in Germany or Popper in the Anglo-Saxon world. He was really a big shot, but sadly, he's become forgotten nowadays by most philosophers of science outside of France. Although his ideas are still very interesting, and he also influenced a lot of great thinkers that still put their mark on the philosophy of science today.
Such as?
For example, Bruno Latour or Michel Serres, or well, maybe the most famous one is Michel Foucault, right?
So you said Gaston Bachelard was focused on philosophy of science. So what was his general take on science? What was he interested in?
What he was specifically interested in was the science of his day, of course. So it was a very interesting time in that period. So from the 1930s up to the 1950s, he had seen the advent of relativity theory, Einstein, quantum mechanics as well, which is a very interesting and challenging field of physics. And of course, chemistry, but also the history of science. So he also was engaging with, for example, astrology and its history, or how the history of chemistry or physics came to be.
So one of Bachelard's most famous books is Le Nouvel Esprit Scientifique, the New Scientific Spirit or New Scientific Mind from 1934. What is this new scientific spirit he's talking about?
The new scientific spirit is, as you say, it new. So what Bachelard basically said in that book was the sciences of our day, relativity theory, quantum mechanics, these are not the sciences that we are used to. They're actually a new kind of science. If you compare it to, for example, Newtonian mechanics, it's completely different. And because of that, we just don't need that old scientific spirit of Newtonian mechanics anymore, but we need a new scientific spirit, a scientific spirit that can work with the new developments in physics nowadays, in science nowadays, with the new character of these sciences. And that's a science that is way more certain about a lot of things.
And what is then the difference between the old and the new scientific spirit?
Well, the key to understanding these differences we can find in a text of Bachelard from 2 years earlier, 1932. He wrote a text called Numère et Microphysique, so noumenon and microphysics, and there he launches the concept of Phenomenotechnics. And he's saying that these new sciences, they work differently than the old sciences. The old sciences, how did they work? Well, the way we still learn it in school today. You have a phenomenon and you translate that into mathematics in formulas, and then you get all these kind of relations and you can describe the world accurately. That's the Newtonian idea of science. You just translate the phenomenon into mathematics. What we see nowadays, well, or in the 1930s when Bachelard was writing, you don't have that clear translation anymore. You can't simply describe the phenomenon anymore. Instead, the phenomena are made using technology, really. So that's why he said it's not a phenomenography, like in the old Newtonian idea. You take a phenomenon, you write it down, phenomenography. It's a phenomenotechnology. You make the phenomena manifest themselves. You make the phenomena instead of just writing them down. That's the new kind of science that he's talking about. And it's still a good tool or concept to understand science even today.
And what would be an example of such a technology that is required to make the phenomena instead of just write the phenomena down that we observe?
A very good example has been the Higgs boson or any of the other virtual particles that you see postulated every day nowadays. These are very clear examples because what's happening is basically what we do, we take the mathematics, we take the formulas, we take the theories, and we say, all right, how can this play out? And we start to explore using mathematics what is possible. And in the end, you end up with a particle that you postulate, a virtual particle that's not discovered yet and might in your lifetime not be discovered. But if it's there, then we're going to use technology to make that particle happen. If you take the Higgs boson again, it was postulated in the 1960s, I believe, by Engeland and Brout and Higgs, of course. At the beginning of the new millennium, it was almost there. So in 2012, the Large Hadron Collider announced they had discovered the Higgs boson. So after nearly half a century, the Higgs boson was technologically made. The phenomenon got technologically produced.
Okay, now we have an example, but what is precisely then Phenomenotechnique? How does it work? What can it do for us as a concept?
What Phenomenotechnique does is it can show us the link between these strange theories, these postulated entities, and our everyday experience. What Phenomenotechnique does is it gives us a concept to think about the link between this particle that's very elusive and hardly found, and it's just a mathematical construct, and how we can translate that to an image on a computer screen saying, Eureka, we got it. So it's the link between the highly abstract science and our world that we live in.
So Phenomenotechnique is a way to make abstract theory more concrete. This sounds very much like the thing we started with, namely that technology is a way to translate science into concrete material products like rockets and iPhones. So is Bachelard just after that idea, the same almost classical idea seems of technology as applied science?
No, that would still be too much of the old science. So Phenomenotechnique isn't just, well, it is, of course, making the experiments and making the things reality, but it's in as much also constructing the theory. And to Bachelard, it's a dialectic. The experiments give us new input on which we then apply new technologies, also conceptual technologies, to make new theories and to postulate new stuff that we then can test again, which for the science. So it's not just about bringing these theories into the world, which is certainly a part of it, but it's also constructing these theories. It's making them get together, also linking these phenomena using mathematics. That's what Phenomenotechnique is. Another example is that of the periodic table of Mendeleev. When it was first conceived by Mendeleev, it had, I believe, 90-something elements, and that was it. Nowadays, we have 100 and even more. And the interesting thing about Mendeleev's periodic table is that it already contained elements that were yet to be discovered. So in Bachelard's day, you had the first synthesization of technetium, which is an element which was in the periodic table, but can be found in nature. So we had to make it. And in 2016, for example, we also discovered 4 new elements, which were also made using only just way more technology than 100 years ago was used. To make these things, to make these elements happen, you don't just need technology to put them into reality. You also need the conceptual technology of, for example, the periodic table to know what you have to make happen, right? So that's Phenomenotechnique.
It reminds me of a quite popular idea nowadays, especially in philosophy of technology. When they look at science, I think most of them will indeed acknowledge that science is not just observation, but science is intervention, creation, construction. So I can predict most philosophers of technology will be interested in Bachelard, but at the same time also wonder, isn't it the same as the thing we already know? Namely that science is indeed intervening. What does Phenomenotechnique add to that picture of science as construction, science as intervention?
Well, of course, authors like Bruno Latour indeed have made this point. They even used the same term as Bachelard. He got it from Bachelard. But his notion remains pretty one-sided, as I just said. It's not just making things happen in the world, it's also this conceptual story, right? So Phenomenotechnique for Bachelard, the one thing that Latour got right from that is certainly the materialization of science, but the conceptual side of the story is at least as important, and also the mathematical conceptual side. So that's where the added value of Bachelard can be found.
These other philosophers of technology, they have no room for the conceptual, the mathematical, the theoretical in that sense. They reduce it to material technology and practice. As you said, mathematics can be seen as a technology as well.
What you said about construction, I suppose he would really be a fan about that, because he was something of a constructionist himself. But indeed, the point where he would say that the others, the contemporary philosophers of science, let it down a bit is that they actually still are in this old scientific spirit. What they actually do is still thinking about, all right, we have this phenomenon, now let's do an experiment. Whereas what it actually means is we're going to construct phenomena and not just take this X and corroborate our stuff. No, it's also the conceptual engineering.
So what do you mean when you say that the contemporary philosophers of technology still are trapped somehow in this old scientific spirit?
Well, if they only use the technology as a means to an end, namely to simply corroborate their theory, that's the Newtonian spirit almost in its purest form, right? It's just saying, all right, the ball will fall along this trajectory. I told you I was right. And that simple materialization, only the materialization, that's lacking actually in our description of science. It's not about the pure materialization. No, it's about the whole process, the whole dialectic that's taking place. The materialization is only one step in a circle of, well, scientific becoming that is bigger than just the materialization of stuff. So what the contemporary philosophers of technology seem to do with the term is a reduction of the phenomenon. Whereas Bachelard would say, no, it's not a reduction of a phenomenon. You don't take the phenomenon and reduce it to the theory. No, you produce the phenomenon. You don't reduce it, you produce it.
And what do you precisely mean with the reduction of the phenomenon in these philosophers of technology?
What they basically do is they only bring about the phenomenon with the idea of, all right, now we have established that this is a thing. Whereas for Bachelard, it's more about, no, we have all these possible kind of things, and we have to see how these things interlock together, and we will try to make this thing manifest itself, and then we can see what happens if we do. And if that has happened, then we can produce all new kinds of things and move forward in our dialectics. So that's why they remain somehow in the old scientific spirit, whereas Bachelard takes the ambiguity at the beginning of it as central. They take the certainty of the phenomenon as central. Of course, in the beginning, you don't know that it's real, but when it's manifested once, you say, oh, right, it's real. Whereas for Bachelard, it's more about the scientific process itself, which is way more ambiguous in its conception.
Would it then be correct to assess that what Bachelard offers us with this notion of Phenomenotechnique is a way to focus on the role of technology, not just, as you said, in this almost final step of materialization, but also in the other steps of the scientific process, that also there technology plays a role?
That is indeed one of the strengths of Bachelard. He sees science as a chain of different technologies, but also different people and ideas where concepts get tied together. You have a theory, but also where personal lives of scientists get tied together. You have a laboratory, or where physicists come together. You get, for example, CERN. That is indeed one of the great strengths of Bachelard, to see these things not as just linked together technologically or theoretically, but also socially.
So there is a strong social dimension in Bachelard's take on science, and perhaps even in the notion of Phenomenotechnique.
Yeah, he certainly has a social notion of science. He even speaks about science as the scientific city. So it's almost sometimes a concrete place for him, like the scientific city with different boroughs, like the borough of physics, where the physicists live and work and do their thing. He even has a workers' union for the workers of the proof. That would be the technologists. And he seems at one point very aware that science is a social undertaking and that it's made by scientists, by humans, by the scientists in her laboratory, by different scientists in their laboratories, actually, many scientists coming together. On the other hand, I also believe that he remains somewhat unaware. He's too optimistic in this view. It's like the scientific city it's a happy place for him. Whereas I believe that there's much more strife going on in that city.
What do you mean with the latter part, that there is more conflict in science than Bachelard acknowledges?
Yeah, for sure. And also, I believe there are contingent things happening in science that Bachelard doesn't always necessarily see or do. Despite him being an historian of science, I believe that he sometimes remains too optimistic. There's much more at stake and there's much more happening in developments in science than he seems to accept. When one theory is, chosen over another one, this is most of the time it's a social thing. Most scientists seem to agree on this one theory, and how that comes about is a matter of, social pressure or even politics, if you like, which seems sadly sometimes lacking in Bachelard Scientific City. So it's a political undertaking where Bachelard seems completely blind for the power play that's happening behind the scene.
And what examples are you thinking of?
Well, of course, one of the examples where I always go back to is quantum mechanics. So in quantum mechanics, at one point, they settled on a theory which became the standard theory of quantum mechanics. And over the years, many other theories have come about, and they were oftentimes downplayed. Even today, it's said they are just disproven, which is factually false, but it's one of the rhetoric strategies, and it's one of the power struggles going on present day in quantum mechanics is actually how we interpret some key experiments. And the way quantum mechanics is today is basically purely an effect of contingent factors which happened almost a century earlier.
The concept of Phenomenotechnique thus offers us a kind of conceptual advantage. It would lead to better philosophy of science. But are there other advantages, reasons to why we should use that concept?
Well, it is an academic discussion on how to understand science, but I think it will be a pity to leave it at that. Properly understanding science also has a societal value. If you look, for example, to deniers of evolution theory, generally these people are somehow stuck in an old conception of science where science only yields conclusive evidence. Whereas in the new science, as understood by Phenomenotechnics, you don't have conclusivity that clear anymore. There is ambiguity all around, and I think it's very important to understand that. And if we understand that, then I think that we as a society make huge steps ahead.
So science denialists have a wrong conception of science and therefore apply incorrect, overambitious, or simply wrong criteria on what good science is. And the problem might then be the underlying conception of science. And if we correct that conception, we can perhaps also counter their classic narratives of science denialism.
Yeah, I believe so. It really boils down to the idea of conclusivity propagated by old scientific spirit. So think again of Newtonian mechanics. Newtonian physics is actually that straightforward. There's no wiggle room whatsoever. It's conclusively true or nothing at all. And that's the old scientific spirit, which simply isn't true anymore in science. Maybe it was in the time of Newton, but that's not how science works anymore. And most of these movements that critique science as just a theory or wrong, they don't get that nuance that it's not about conclusivity anymore. We also saw, for example, with the pandemic now, that the general public had a hard time to understand that science progresses with uncertainties all around it. You just can't walk up to an expert with this new kind of virus that's a month old and say, well, what are we going to do now? She will also be at a loss, but at some point she'll know better than any of us. And then 2 years later, it's easy to retaliate and say, well, you didn't know anything about it, did you? Whereas, of course not, because it was the cutting edge of science at that moment. And there were ambiguities all along, and there still are ambiguities about it. And they're trying to clear up as much as we can. But in the end of the day, ambiguity always wins. I mean, the more you discover, the more questions you inevitably will raise. Although at some point they become so abstract that it's not clear to anyone that's not an expert anymore that the ambiguities are there. So that's why we still have this idea of an absolute certain science. But I also think that this is because, well, we get taught it in school, whereas we should actually instruct ambiguity, which is actually a slogan of Bachelard's.
Another example would then be, for instance, this current reluctance of some groups to take vaccines. We only take it if it's absolutely certain that it's safe.
Yeah, the problem there is, I believe actually that they only look at that number with 99.999% certainty, so not 100. But that is the problem that Bachelard would say, if you only look at that number, then you're only looking at certainty, then you're still in the old scientific spirit. Whereas with the 99.99999% certainty, you have to understand why it is like that. You have to understand the whole process that's taking place in science and why there still is unpredictability and where the gaps are at and how it happens or progresses. In fact, if it would be 100%, that would be a sorrowful state for science, because that would mean that everything's clear now and progress has come to a stop, and that's it for science.
So if this incorrect image of science is the issue, what is then the solution? How to solve the problem? Does Bachelard provide us with any answers?
Yeah, I think a pretty clear one, namely education. Bachelard himself was an educator. He taught in high school and then later, of course, as a professor at the Sorbonne. Education is really the key. He's written this book, Formation of the Scientific Mind. And there he really says what we should instruct is not certainty, but is ambiguity. We should form our younger population to understand ambiguity and to go about with it, to play with it in some kind of way, to technically manipulate the ambiguity, to take the ambiguity and construct it in such a way that we get new ambiguities, so we can produce new phenomena, so we can produce new ideas. And that's how science progresses. I believe if we can educate this to our younger population, then things like anti-vaccination or flat earthers will have a harder time to recruit new recruits, I'd say, because they'd understand that science is not just getting the facts and writing them down, but making the facts.
We need to teach the new generation a new view or image of science. Does technology play a role in that educational aspect as well? Is there a room for Phenomenotechnique in this pedagogical project?
Certainly. It's easy to see today that technology is elemental for education, but it should be more than just a tool to get a live stream to your class. It should also be understood what technology is, how it comes about, the whole process of technology. And if we understand what technology is, how it comes about, then we set giant steps. There's this example of a flat earther using internet satellites all across the globe to send his message of it's flat, you guys, whereas he doesn't understand how any of that works, but he's certain that it's flat. Whereas if we would understand everything behind it, it'd be nonsensical to say it's flat.
And why would it be nonsensical?
Because you know about these satellites, you know about how the internet came about, the social things that happened to make it work, all the troubles that had to be solved, all the engineering that went ahead before it could happen. If you'd see how this technology is possible or how certain facts become technologically made, then there'd be no point in saying that's flat, because with any technology you try to use, it wouldn't work.
Because all these technologies presuppose that the Earth is a globe.
In a way, Bachelard speaks of technology as reified theorems, and in a sense, that would be right, but you also have to understand the dialectics. They're only made that way because the world is that way. You could try to make technologies using Euclidean geometry, and to a good point, you get pretty far. But I don't know, to send Voyager out of the solar system, that'd be another story where you are destined to fail, because the theories that you would use for it don't resonate with reality. And that's actually what Phenomenotechnique is about. It's taking the phenomena and trying to construct them. And in doing so, you get to understand reality because it's in a constant dialectic with what you're doing, because you're making them in the world and you are also constructing them in your mind. And if these two don't fit together, then, well, the dialectic won't happen. So you become static, which is, well, detrimental to Bachelard because his philosophy is all about movement. He wants to progress. And I think science should also progress. The moment it stalls, it's a sad day for science.
So Bachelard's notion of Phenomenotechnique seems to have a number of interesting aspects, advantages to use it. But as you briefly mentioned already, Bachelard is a bit forgotten. So let me just basically end with the question, do you see any change there? Do you think Bachelard will come back into the picture of philosophy of science, philosophy of technology, or are you more pessimistic?
Well, I hope certainly it's not going to be the latter. You have developments in philosophy of science. He's currently being rediscovered a bit. I believe that's promising, but regardless of that, I think the least we should do is look at his ideas and confront them with contemporary issues. If you do that, then you see that Bachelard has much to offer. Not only the notion of phenomenotechnics, but also his understanding of science as something social. The necessary plural aspects of his philosophy of science is also very interesting and could be very useful to current debates and for example, discussions about scientific plurality. So yeah, there's a lot that Bachelard has to offer, and it'd be a shame to leave a thinker with that many good ideas cast aside.
So Phenomenotechnique offers us a way to conceptualize this difficult relation between science and technology in a very interesting way. I think we have discussed a number of reasons why Bachelard's Phenomenotechnique has something to offer for contemporary philosophy of science, philosophy of technology, and even beyond that. Thank you, Hannes, for being here today. It was a very interesting discussion, and hopefully we will meet each other in another episode in the future. Thank you.
Thanks for having me, and I look forward to it.